You're welcome once again to my YouTube channel. Thank you for stopping by. This is the second part of the video on similar shapes. All right, we have looked at the basics. We've even answered some exam style questions together. Please ensure you watch that video. I'll be leaving the link right here and also in the description box. So let's get right into question number 5. Now, we're told here that triangle ABC is mathematically similar to triangle PQR. The area of triangle ABC is 16 centimeters square. I'm going to put that right in here, centimeters square. All right. And we have been asked to find the area of triangle PQR. Now, since they are mathematically similar, it means that there is a link between the lengths of their sides. It is this same link that affects their area. So if we can find the link between the lengths of their side, that link being our linear scale factor, we would use that to get our area scale factor and then find the area of QR. All right. So let's get right into it. What is the linear scale factor? The linear scale factor will be the relationship between corresponding sides. Here, AB corresponds to PQ. So we are going to look at the linear scale factor using PQ over AB. So the linear scale factor is given by PQ over AB, which is what? 12 over 8. And to its lowest term, this will be 2 and 3. So this will be 3 over 2. Now we know our linear scale factor. Our area scale factor is given by our linear scale factor square, which is what? 3 over 2 all square. Now, 3 over 2 square will be 9 over 4. Now we know what our area scale factor is. To find the area of PQR, so all we need to do is to multiply the area of ABC by the area scale factor. So area of PQR will be equal to 16 multiplied by 9 over 4. Okay, 16 multiplied by 9 over 4 is going to give us 4 here, 1, 4 here, 4. So 16 multiplied by 9 over 4 is going to be giving us 36 centimeters square. Now, we're told that the triangles are the cross sections of prisms, which are also mathematically similar. Excuse me. Now, let's talk about prisms for a bit. Prisms are 3D shapes that have a uniform cross section. What do we mean by that? It means that as you go along the length, you see exactly the same shape. For example, a typical loaf of bread has a uniform cross section. So it could be regarded as a prism. That is why your cuboid will be regarded as a prism. I hope you get that. Prisms should be differentiated from pyramids that have a vertex, but your prisms have a uniform cross section. So this particular shape, to find the volume of any prism at all, what you need to do is to find the area of its cross section and multiply it by its length. That's all you need to do. Area of its cross section multiplied by its length. All right. So in this case, the cross section given for this shape or for these two shapes will be these triangles. So if we are given the volume of the smaller prism, we could easily find the length of the smaller prism. Why do we need the length of the smaller prism? Because the question is asking us to calculate the length of the larger prism. So if we could find the length of the smaller prism, we would apply our scale factor, our linear scale factor that we got here, and then use it to find the length of the larger prism. I hope you understand. So we just established that volume is given by area of cross section area of cross-section multiplied by the length. So the length will be given by volume over area. We've just made length the subject of our formula. So our length for the smaller prism, for small, will be what? The volume, which is 320, divided by its area, given previously as 16 centimeters square. So 320 divided by 16, that will give us 20 centimeters. Now, that's the length of the small one. To find the length of the large one, length of large, all we need to do is we multiply our length of the small one by our linear scale factor. We established that our linear scale factor is 3/2. So doing this, it gives us 10 here. So 10 times 3 will be 30. So the length of the larger prism is 30 centimeters. All right, let's move on to the next question. This is my favorite question here. I like the fact that this question is integrating a whole lot of things. It's helping us remember our knowledge of triangles generally, our knowledge of triangles in circles, our knowledge of angles in parallel lines. Some people are wondering, how can you see all of that? Well, I can see this is a circle, and the question reads, C lies on a circle with diameter AD. The moment we are told that the diameter is AD, we need to remember the rule that says that if there is a triangle inscribed in a circle and its longest side happens to be the diameter of the circle, then the third side, that is where the other two sides meet at the circumference, will be angle 90. It's going to be a right angle. So this is angle in a semicircle. The angle in a semicircle is 90 degrees. All right. The next statement here says B lies on AC. This is AC here. And E lies on AD. AD, remember, AD is the diameter, such that BE is parallel to CD. Now, the moment you see the word parallel and this arrowhead here, you know that these two lines are parallel. You need to start thinking about angles in parallel lines. Now, when we have parallel lines like this angle should be equal to this angle. Why? Because they are corresponding angles. In the same vein, this angle should be equal to this angle. Why again? They are corresponding angles. Now, since those two pair of angles are same, definitely the angle at A should just be the third angle in your triangle. Now, if you look critically at this diagram one more time, we have been able to identify all the angles. We have seen that this angle is same. The angle at B is the same as the angle at C. They are both right angles. The angle at E is the same as the angle at D. Okay. And angle A is just here on its own. If we bring out those triangles, I want to bring out the two triangles that are in this diagram. Okay. If we bring out the two triangles, the smaller one is ABE. ABE. Okay, with the right angle here. And this is 13.5 centimeters. The larger triangle is ACD. Sorry, I've mistakenly labeled it wrongly. So let me fix that. Okay, ACD. This is A, and this is C, and this is D. All right, so this is a right angle also. We know that these two angles are the same. So, and this is angle A anyway, so they are the same. So this shows us that we have two similar triangles in this circle. So that is the concept we are going to use to answer the question. What really is the question? We are asked to work out the radius of the circle. The radius of the circle will be half of the diameter of the circle, and we know the diameter is AD. So all we need to plan to do here is to find the diameter of the circle. The moment we can find the diameter of the circle, then we'll half it, and then it will be our radius. In our bid to finding the diameter, the first thing we need to do is to find the linear scale factor. Why am I particular about it? Because if I know the linear scale factor, it's going to help me in finding my AD. You're not sure yet? Just stay with me. Let's find our linear scale factor. The corresponding sides are CD and BE. So my linear scale factor is going to be what? 18 over 13.5. Simplifying this is going to be 4 over 3. That's our linear scale factor. Do we need it right away? Not yet, but we're going to need it pretty soon. So let's just keep it right there. Now, since this triangle ABE is a right angle triangle, all right, and we know AB, we're given AB. AB is 21 centimeters. We can find our AE. All right. How do we find AE? Since it's a right angle triangle, we apply our Pythagoras theorem. Pythagoras theorem says that AE square, which happens to be the hypotenuse here, should be given by the sum of the squares of the two other sides. So AE square should be AB square plus BE square. All right. So AE square is equal to 21 square plus 13.5 square. So our AE should be equal to the square root of 21 square plus 13.5 square. All right. If this is evaluated correctly, our AE is going to turn out to be 24.9649 and so many other numbers. All right, so we have found our AE. Our AE is the corresponding side to the AD we're looking for. Remember, we're looking for AD because we need our radius. AD is our diameter. If we find AD, then we just half it to get to get the radius. So AE is going to help us with that. Now that we know our AE, our AD is what? The scale factor. Yes, remember we found the scale factor earlier. The scale factor, which is 4 over 3 multiplied by our AE, 24.9649 and so on. When you do this, you're going to have your AD as 33.2866 and so on. Okay, remember we need our radius. Radius is AD over 2, which is what? 33.2866 divided by 2. When you divide that by 2 and give your answer to 3 significant figures, is going to be 16.6 centimeters. I hope you understand this. I hope it's clear. Please go over it. We are asked for the radius of the circle, but we need to be able to see from this diagram that we are dealing with two similar triangles. Okay, thank you for watching. All right, see you in the next one. Oh, wait, have you subscribed? Have you liked the video? Please do. Thank you. See you in the next one. Bye.